I'm going to work through a few of these review problems for you, just for some extra practice and review and some explanations on the solutions. So I've circled the ones that I'm going to go through so you can follow along and listen to the explanations that match the answer key. So the directions say, using the GCF, factor each polynomial. So that clues us in that we should look for a greatest common factor. So if you look at 10 and 22, is there a number that goes into both of those? Yes, the 2 goes into both of those. Now look at common letters. Well, you have a to the 4th here and a to the 3rd here. So how many a's are in common? Well, 3 of them, because the other term has 4, but only 3 are in common. So our greatest common factor is 2a to the 3rd. So that means my answer is going to be 2a to the 3rd, that's my greatest common factor, times what's left when I divide by that GCF. And so here, that's what factoring means. It says find the two things that get multiplied together that will equal this product right here. So what we do then is we divide each term by the greatest common factor. And when I take 10 and divide it by 2, I get 5. And when I take a to the 4th divided by a to the 3rd, I get a to the 1st. Divide the second term by 2a to the 3rd, and 22 divided by 2 is 11. So I get 11, and a to the 3rd divided by a to the 3rd is 1. 11 times 1 is 1. So because it's positive, then that just becomes 5a plus 11. So when I multiply 2a to the 3rd, the greatest common factor, times the remaining factor, 5a plus 11, that would equal the product. So this is my answer. That's every single time we factor, we always look for a greatest common factor first. So let's go down to number 11. We are still looking for a greatest common factor. So 24, 16, and 32. Well, 2 goes into all of those, but we are also trying to look for the largest number that goes into all of those terms. And so 8 is the largest number that goes into all 3 terms, but then look for common letters. I have x squared, I have x to the 3rd, and I have x to the 1st. So the most x's in common is 1, or x to the 1st. Then I look for the y's. I have y to the 5th, y, and y to the 4th. So again, y to the 1st is the largest number of y's I have in common. So my GCF is 8xy. So again, my factored form is going to look at like one factor, my GCF, times the other factor, and the other factor I get from dividing by 8xy. So that would give me 24 divided by 8 is 3, x to the 2nd divided by x to the 1st is x, and y to the 5th divided by y is y to the 4th. That's that first part when I divide. Now I'm going to divide the second term by 8xy. The sign stays the same, but 16 divided by 8 is 2, so I'd have negative 2. X to the 3rd divided by x to the 1st is x to the 2nd, and y to the 1st divided by y is 1. And so I'd have times 1, which would keep it negative 2x squared. And then last but not least, when I divide this by 8xy, 32 divided by 8 is 4. And then x divided by x is 1, and so again, times 1 would still give me 4. And then y to the 4th divided by y is y to the 3rd. So again, those are my two factors that when I multiply them together, I would get 24x squared y to the 5th minus 16x to the 3rd y plus 32x y to the 4th. And you can always check your answers by multiplying them back together. Okay, the next problem says factor each trinomial, okay? When you have a quadratic trinomial, okay, that means you have 3 terms with degree 2. And when we have the simple ones, where the value in front of x squared is 1, then we can look for the 2 numbers that multiply to 18 and that add to negative 11. So I start listing factors of 18. Well, I think of 6 times 3. Well, that's going to add up to 9. Or even if I make them both negative, that's going to add up to negative 9. So that's not going to work. So, but what about 2 and 9? Well, 2 and 9 add up to 11. That I need negative 11. But if I take negative 2 times negative 9, multiplied together, that gives me positive 18, and added gives me negative 11. So these are the factors that will give me the product of 18 and the sum of negative 11. So those are the factors that I put into my two parentheses. So my negative 2 goes in the back, and so does my negative 9. And what goes in the front is whatever variable you have. And remember, I've tried to talk about this several other times before. And when we do the guess and check method, it's really important. But remember, the first term times the first term in each parenthesis always is going to equal the first term in your quadratic trinomial. And the last term times the last term is always going to equal the last term. And how you get that middle term to get negative 11x, there should be an x there actually, is by taking the outside terms together, which is negative 9x, and the inside terms together, which is negative 2x, and adding them together. So just keep that in mind, because when we get to the more challenging ones where we have to guess and check, that could be a strategy you use. Okay, this next set of directions says to factor each polynomial, remember to check for the GCF first, and then sometimes you can still factor it. So if I look for a GCF, 7, 28, and negative 35, 7 goes into all of those terms. There's also a Q in each one, but there's only one Q in common to all three terms. So when I factor out a 7Q, I would be left with Q squared plus 4Q minus 5. So now, if I look at this, can I factor what's in the parenthesis more? Well, you're looking for, again, there's a 1 in front, so you could look for two numbers that multiply to negative 5 that add up to 4. Well, if you have 5 and 1 that multiplies, oh, this has to be negative 5. So one of those would have to be negative. So either negative 5 times 1 or 5 times negative 1. Well, this choice right here, when I multiply together, that gives me 5, negative 5, but adds up to positive 4. So that choice doesn't work. But if you look at the first choice we did, those multiplied together equal negative 5 and add up to positive 4. So actually I had it right the first time, I'm sorry. All right, so now when I factor this, remember those two numbers are going to go into my parentheses, and what goes in the front is whatever letter I have. So in this case it's a Q, and then what still goes out in front, don't forget, is that 7Q you already factored out. So then my answer is 7Q times Q plus 5 times Q minus 1. All right, let's look at number 25. Do you have a GCF? We're still on looking for a GCF. Well, there is a number that goes into both 3 and 48, and that would be the number 3. And there's also an A in each, so my greatest common factor is 3A. When I divide by 3A, I get A squared minus 16. Now, this is a little bit tricky because you might think, oh, well, that can't be factored. But this is one situation where, again, you notice that there's a 1 in front, and we can find two numbers that multiply to negative 16 that add up to 0, because this could be 0A in the middle. And so now we can find two numbers that multiply to negative 16 that add up to 0, because they have to be the same number. One just has to be positive, one has to be negative, and 4 times negative 4 multiplied gives you negative 16 and adds up to 0. So now I put my A's in the parenthesis, and I remember to bring my GCF along. All right, the last one I'm going to do, again, I'm looking for a GCF. So if we look at these, 2, 5, and negative 3, there's no number that goes into each, and there is no letter in common. There's not a 1 in front, so I can't use multiply and add up. what I can use is either guess and check or another strategy, like the box method or some of the other methods we've gone through. If I go ahead and do the guess and check method, I know, again, that the first term here times the first term here always has to equal the first term. So n times n gives me n squared, so this is going to have to be 2n times n, and that gives me 2n squared. Remember that the last term times the last term always has to equal the last term. So the only way I can get -3 is multiplying 1 times -3 or -1 times +3. So now what I need to do is I just need to pick one of those combinations and try it and see if it works. Okay, so I'm going to try this top one first. So I'm just going to put in 1, so +1 and -3. So now I'm going to multiply those outside terms together, which gives me -6n, and the inside terms together, which gives me 1n. And if I combine those together, that would equal -5n. Well, that's pretty close because what I need it to equal is positive. So all I need to do here is change the signs and make this minus and this plus. And now what happens is I get positive 6n and I get -1n, which gives me my +5. So now I have the right combination with guess and check. I'm going to go through this question also with the method that we worked on a few times in class that some students are finding helpful, where we take 2n squared plus 5m minus 3, and we take these two numbers and multiply them together, which gives us -6. Then we find factors that multiply to -6. So I'm looking for factors that multiply to -6 that add up to 5. So that could be that could be 2 and 3, but one of them would have to be negative, but those don't add up to 5. So then I could also try 1 and -6, or -1 and +6, and that combination right there would add up to 5. So those are the numbers that I put in the back of my parenthesis, -1 and +6. What goes in the front of the parenthesis in this one, which is a little different, is my 2n. So I am going to put 2n and 2n. Now, some teachers call these fake factors. I'm not a big fan of that language, but if we divide this parenthesis right here by a greatest common factor between these two terms, there is no greatest common factor except 1. So that parenthesis stays the same. If I divide this by a greatest common factor that I have of 2, then I would get n plus 3. And now you can see that this answer that I have right here matches what I've already done. And so I factored the first time with guess and check and the second time with the other method. And of course, you could also use the box method as well. So I will go through that, but if you're not interested, you could just stop the video at this point. But with the box method, okay, we draw a circle in the middle, and then we write that quadratic trinomial in the boxes diagonally. So 2n squared plus 5n, and then minus 3. Then what we have to do is we have to multiply the 2n squared, or the ax squared, times the c, which gives us -6n squared. So this is our ax squared times c. And then we find factors of this that would add up. So again, I'm finding numbers that multiply to -6n squared that add to 5. So since I already do that, I know that it's going to be 6n n and negative 1n. Those are my factors. So I put them in here. And then in this model, what I have to do is I have to factor out a GCF from each row and column. So if I factor out a GCF from this row, that would give me 2n. And if I factor GCF from this row, that would give me just a negative 1. Then I do the same thing for this row, which would be factoring out an n only. And from this row right here would be factoring out a 3. And so now my numbers on the top form one of the parentheses, and the numbers along the side is the other one. So again, you can see we got the answer, same answer, 3 different ways of doing it. But I just wanted to go through a few for some verbal explanations.